Okay, so we're going to talk lesson 9. Lesson 10, I mean. We did lesson 9 the other day. That was the notes from yesterday. And here we have Seahawks rushing and receiving yards from their 2018 season. All right, I know it could have been better, but that's what happens. What's the greatest interval where the number of receiving yards increase from game to game? Well, let's interpret the graph.
Is this actual stats?
Yeah, it is. Taken from ESPN.com/NFL/game/space/game/game ID. Yeah, you can go search it up. All right. Okay, I can't click on it because it's actually the paper. All right, but the point is, what's the greatest interval where the number of receiving yards increased? So,
350 and 75.
where are you at?
On the 11
11
and then to 13.
to 13. What? Where's the misspell? Oh, Seahawks. Okay. All right, well, anyway, we need this one to go away. Don't worry about it. That's the right one. That's the wrong one.
But that's the left one, not the right one.
All right. So, wait a second. We're talking about increasing. That's what it is. I guess the greatest interval where the number of receiving yards increased, if you go from game 4, it's increasing to game 7. So that's a 3-game increase. If you go from game 9 to game 11, that's a 2-game increase.
What's the degree? Yeah, but what about like? Wait, is it off? Is this supposed to be off?
It's from 4 to 7.
What about like up?
Mr.
No,
Wyatt?
not
the
over.
game
It's off. Like the numbers in the grid doesn't make. It's just in between.
It's from 13 to 14.
So that's what I'm asking. Is it supposed to be
13 to 14, well, it's still increasing from that point on, too. So we're talking, where is the receiving yards increasing? It's all of that stretch.
It's not talking about
True.
It's
So
not
13
the
to-
amount of increasing, but how long they're increasing.
That's a different question, and you're exactly right. Exactly right. So let's see what James Harden went on a 32-game streak where he had over 30 points per game, right? And it was broken like last night. But the point is, for 32 games, he was getting consecutively 30-plus points. So that's, in essence, what we say about the greatest interval. For how long are we seeing an increase in the amount of rushing receiving yards? 13 to 15?
Yeah.
Okay, that's only 2 games, though.
It's 3 games from 4 to 7.
3 games from 4 to 7. From game 4 to game 7. So in the postseason game, notice it's only singular. In the postseason game of 2018, Seattle rushed for 174 yards. The Seahawks. All right? I think they didn't want to write it a second time. So what's the difference between this number and Seattle's highest rushing number of the entire season?
4,000.
4,000. Have you ever watched football? Okay. So what's the highest rushing game for the Seahawks?
275.
125.
Right? In terms of rushing, so we have the other graph. That's this spike right here. Where is 174 in relationship to it?
Plus the
Yeah. So Anson's, it's all over the place. So try to get centered here. So their highest game is approximately 275. And their postseason is 174. You know. So our answer is approximately 100.
Where's your 2?
Yeah, this is the shape for similar. Like this triangle is similar to this triangle.
How are they similar?
They have the same angles. I will answer that question. You be careful what questions you ask me.
Mr. Then,
How much information do you want to hear from me?
no.
None, he says. What's your grade right now? Okay. X-intercept. We're just going to delete all this footage. All right. X-intercept. The point where a graph crosses the...
Y-axis.
It's an x-intercept. The letters have to match. But at this point, y equals 0. So then a y-intercept is the point where the graph crosses the y-axis. Yes, indeed. Hopefully this is somewhat review. Interval. It's between two numbers.
Wow.
X is equal to 0.
All right. The word interval is used to describe numbers between. I don't actually know this one, so I'm gonna go look this one up. Hey, I gotta make this go away.
It's numbers between two intervals. It's the word.
The word interval is used to describe numbers between two. Are you sure that's the one though?
So you're cheating. What a cheater.
Not cheating at all, mister.
Cheater fucking called using your resources. Are
So
you
we can use our resources during tests?
No.
Can you be my resource?
But see, if she's your resource, that means that you need a crutch. Can't you stand on your own 2 feet?
Oh.
I don't need your help to eviscerate a student's confidence. I'm giving you none.
Hey.
Hang on. There's a lot of like places to go. This will be recorded for posterity, so you know how much stuff we have to go through. Hang on, we're gonna find out the answer to what goes. I don't think it's the word interval is used to describe numbers between two numbers,
I think it's 2 points.
Go down.
2 points,
still doesn't
two
say-
things. I think we can do better.
I'm cutting my hair tonight.
What a random comment.
I know. What?
But thank you for sharing.
What? Whatever.
Okay, here we go.
I did not-
Let's see what a maths dictionary for kids
Make it all easy.
between two specific values.
So basically points. For kids?
I literally. No, you're not the one we think.
You did not put that. You're a liar.
Well, now we know what you think of us.
So basically it's 2 points.
What is this?
2 points on number.
Then why do they keep calling you
Okay, turn the page.
Wait, mister.
Oh my gosh.
Why'd you put a question mark?
I am going to post this, and your class can watch whenever you want.
Okay.
It's going to be like a 5 gigabyte file. All right, here we go.
That's a lot.
That's the thing. Hey, what's domain?
Number.
The set of all
Numbers.
inputs. Maybe that's the wrong word. Independent. That's the better word. We can go search to a maths dictionary for kids to find out what they think it should be. No, I was about to, but I should. How dare you distract me like that? Okay, it's all of the x values in the function. Therefore, what's the range? Because that's the letter D. I just can't write. Okay. The average rate of change. I feel like we're missing something. The range of a function is the set of all. It could be or all of the f of x values. I'm going to insert my own line right here. I can do that. I have a degree. Prove it. Prove that I don't. Okay. Actually, when I graduated from Central, the Alumni Association, which it's since degraded, but they gave me a wallet-sized diploma, laminated, so I could put it in my cart in my wallet and be like, "You want to see my degree?" And then pull it out and be like, "Here it is."
Do you actually have it?
I know.
But it's like it's been folded and bent and gone through the wash, so it looks gross. But yeah,
You put your wallet in your pocket.
sometimes it happens. Okay.
Mister, you gotta
You totally
be
forgot.
something.
Sorry, I'll put my.
Okay, yeah, that's true. I didn't think it.
Like it's folded.
I put my phone in the washing machine.
Okay. The formula for average rate of change. We're gonna write 3 fractions: delta y over delta x, and delta means change. Well, do you know why it's a triangle shape on the Delta Airlines logo? Okay, that's true. They need to. Okay. Actually, I flew Delta this summer. It's pretty good. Pretty nice. All right. The change in y from last year to this year, hopefully you remember, is this notation. I don't care what you like and don't like right now. Okay? Well, it was last try, but I think remember you talked about like the rate of change from last year. Oh, that's right. I taught you this. Okay. I like the royal we. Okay. So I watched Ralph Breaks the Internet. It's pretty good.
Nah, it looks dumb. Wreck-It Ralph. Number 2. Are you kidding me?
You feel like That's.
I hate those movies.
All right.
Watch it with your kids or by yourself.
Well, both. But anyway.
Wait, go back up.
Why?
Because we're riding.
Oh.
We're riding our bikes.
It's tough to say that. It's fine. I understand.
For some
No
people-
condemnation from me. The rest of the class, they're ridiculous.
You just spit on my
I just
face.
pulled out my hair.
I would like to talk about example 2. Are you ready?
Hold up, no. Please, I'm whiting my wife. Alright, I'm done.
Wow. Okay. Use the graph to answer questions. On what interval is the function increasing?
Point zero. 0, 1, 2, 4, 2.
It's over.
It's all of them.
I literally just talked to myself, but I didn't even care.
Like you did.
Yeah, really, I mean, just because the graph only goes to -10, it does extend to the left continuously. Name this, by the way. This is an exponential function.
You also call it
What?
Wow, I just spelled 4 wrong.
Okay.
Why is it exponential?
Well, let me actually talk about 2 specific points on this function.
What is all this?
It's just
Fine, Jacob. I'll talk about one more.
3.
Oh, I thought it was wrong.
From 0 to 1, what's the change in the x? But what's the change in the y?
1.
Oh, 1, 1. From 1 to 2, what's the change in the x? But what's the change in the y?
2. So
What?
it's exponentially getting bigger.
Right. What's the factor, like the amount of change that is happening from this slope triangle to this one?
2x.
Well,
No. 2x.
what about at 3? It's not on the graph, but what's 3 going to be at?
8.
How do you know?
Because
Say it though, because you're right.
times by
Yeah, we're timing it by 2, right? So we went from a height of 1 to a height of 2 to a height of 4. I guess if I talk about these values that are the heights, 1, 2, 4, do you see a pattern here? What's the next number in the pattern? That's called the scale factor, the growth factor. That's what's the other word we use for it? Well, it's the exponential growth factor. So the y-intercept, 1, but the average rate of change, well, it's a shifting value. So I'm gonna pick specifically 0 and 2. And what Logan drew early in class was from this slope triangle. You drew this thing, but it was the other way around. What's the rate of change here to here?
2.
Oh, 3. Oh, sorry, I thought you were talking about from 0.
Well, it is from 0. It's not from 0, 0.
No, that's what I meant.
Okay.
The origin.
From the graph, using the slope triangle as your method of seeing average rate of change, we go from where the graph is at 0 to where the graph is at x equals 2. Rise 3, run 2, done.
You actually just say the thing you just said. I guess I'm laughing. Are you on something?
Okay, let's go to page 11. Use the following graph to answer the questions below.
11? 12 minutes.
There it is.
Yeah, I was like,
It's gonna be your last page.
I can see it right here, but I can't see it there. Not that that matters.
no, I don't.
Oh, and right here too. Okay, so assuming a smooth curve can be drawn and that they exist,
But it's not a curve, it's a straight line.
just because you call something a straight line doesn't mean it doesn't have curves.
Yeah.
Roasted.
That's true.
Why do you feel like you have to?
But
Okay,
it doesn't have curves.
what's the x-intercept?
Why?
And what's the y-intercept?
X. 2 and negative 3. Smash rice coolers.
It's approximately 2.
Yeah, the equal sign there could probably be best represented with an approximation. We do have a way to be specific to find it. So part of our math for this trimester will be focused on finding the equation of the line. We did a lot of that in the fall trimester as well. We will get to that, but that's mod 4. We're in mod 3. How about the average rate of change? What do you need to do? So that's this dot,
And then the very, very top.
and that's this dot. They're about in the middle. So we're going to make a slope triangle. What's the rise?
2, 5.5.
7. Wait, whoa, hold up. What? I go to
Let me count again just because I agree with you,
7
but
over 4. Wait, are the numbers off?
7 over 12 and a half. Because 7 plus 4 is
yes, they are. But the x equals 1 number is negative 1.5. And the x equals 5 number is 5.5.
That's so weird.
All right? Your job is to do exercise 4 on your own. Homework.
Is it actually, or do you just?
Yeah.
No.
I thought we were doing a problem.
I'm going to make it be on there.
Alright, Mr.
Let's go 12.
Howdy, Mr.
Hold up. Go.
Hey, this one looks hard.
We're looking for specific features from a function. So, first of all, these equations or these graphs were about finding specific points, finding the average rate of change, being able to predict the x and y intercepts. Here we have the actual example. I'm not sure what year this was when they collected it, but this was from what's the one that just died?
Stephen Hawking.
No.
Steven.
The Mars rover that just died like a little bit ago.
Opportunity?
Opportunity. Was it Opportunity?
Yeah.
I think you're right. So this could be from that rover itself. Or the other. What's the other one that went with it?
Wait, what just died? Who died?
There was 2. They sent one and its brother is still going.
Oh yeah, there's supposed to be one.
I don't know.
Oh, wait, one's
It's
supposed
Steve
to last
Jobs.
like
Steve Jobs.
three.
Stop saying people's names, EJ. I'll look it up in a minute. So the Mars rover is collecting the following temperature data for 1.6 Martian days. They call those sols. Use. I don't know why it says freeze on and it's not actually frozen. Okay. Use the graph to answer the following questions. Approximately when does each graph change from increasing to decreasing? Right here, the graph is decreasing
Yeah.
to increasing. So there's a place. There's a place. Because right here, the graph is increasing and now it's decreasing. And do the same.
Right there. No, right there.
This one, I mean, probably, if we want to be picky, but over the course of like 0.1 of an hour or a Martian, day, that's not necessarily going to be that's maybe like a weather, like a dust storm blew in and then it blew out.
Okay, I said today.
This is noticeably different.
Like a candle when a candle blows up.
Sure. Just like that.
10.5 right.
Yeah, let's put 10.5. Okay. So approximately when does each graph change from increasing to decreasing? And the same? There they are. 3 days. 3 time periods. Literally, the graph is pointing down, then it's pointing up, then down, then up. So there are 1, 2, 3 places where the graph changes direction. So when is the air temperature? Notice that's this line. When is it increasing? That is this line.
10.4 it's increasing.
Sure. So let's broaden the interval to not be just specifically at that point.
So from 10.6. From 10.2 to 10.6.
Okay, let's do this in inequality notation.
Thank you.
Where else?
Thank you, sir. What's your point? Money for teachers.
11.5.
Yes, sir.
I mean, if this is 11.4 and this is 11.6,
Oh, no, you're right. Oh, I was thinking it's wrong.
okay. When is the ground temperature decreasing? That's the other one.
See, that's
Whenever
another
it's-
one right there.
Oh, my ears.
That's so loud.
Hey, I think we're gonna do a flag salutes and then the announcements.
Sorry for the interruption. All students that ride bus 4 need to get on bus 6 for this afternoon only.
Let's
All
do the-
students that ride bus 4 need to ride bus 6 for this afternoon
We're
only.
supposed to be doing
Thank you.
announcements.
In fourth, they're supposed to do it, and they didn't.
It's 7.
Seventh period? Wow. Okay, so I'm gonna leave 3 for you to do because it's just like 2, but the other way around. And then, what is the air temperature change for air temperature change on this? I guess this is not specific enough. Let's pick one. Let's go from 10.5 to 11.2. What's the air temperature change from 10.5 to 11.2? Yeah, we can be, using digits of 5.
37 to negative 103. Or negative 103.
Hold on. Air temperature. What's this value right here? Graph? What's this value right here?
28. Which is not a 10.5 by the way.
Well, let's use it in Celsius because, come on, science. What's this temperature value right here?
It says
It says temp in Celsius and then.
I need to make a change. Forgive me.
92.
There we go.
What?
Told you. It's a 6 now.
Well, I want to go from the peak of the air temperature graph right here. And the air temperature graph right here is going at, what is this, 10.6 approximately?
Yeah. You need temperature in Celsius. but it's-
Down
let's
to
do Celsius.
here.
Let's do
Oh, I'll add that. In degrees Celsius. How much, mister? Why do you figure? Are you using the Fahrenheit and the Fahrenheit? Maybe that's a better calculation. Okay, so I'm going to go back here and change the direction to Fahrenheit. So you did, what was the first number that you wrote down? Oh, okay, so just subtract the 2. Well, wait a second. Sorry, now it's level. Are you putting minus or plus right here? You have the 2 numbers, right? You have, well, that's my question though. How are you finding that? My question though is how are you finding that though?
So negative 103 subtract or add whatever 28. But then initial or
You're
absolute.
right, I'm on the wrong one. Okay.
Oh, you think that's what you?
We're living dangerous. We're doing math and pen. So you're on this one. This is the air temperature one.
Water rebel.
And you're going from 28 to negative 103. What'd you get for an answer?
131.
131. Okay. I follow now. All right. So go from 28 to negative 103 is a change of 131. It's negative because you're going down
Oh,
from.
okay.
We measure that all the time, specifically when we talk about change in temperature as it goes from day to night. We measure negative as we talk about your speed on the freeway is 70 miles per hour down to 5 miles per hour when you hit the stop sign. Hopefully 0 when you hit the stop sign. Don't hit the stop sign. Okay. But what's the change in time? Because we got to talk change in temperature divided by change in time. What's the change in time? Point 0.6? Do you have a calculator? Can you go 131 divided by 0.6? If we do change in temperature divided by change in time, we're going to get the average rate of change along that interval. 218, and then it repeats. 0.3 repeating. I'll just write it like that.
208.
It's also negative. So, although this is over 0.6 of a day, if we were to extend this to a whole day, there'd be a 218 degree temperature change.
Wow.
It's also, super cold. So, you're not really experiencing that in terms of heat. It's, you go from ice to, like, nitrogen, which is really cold.
Wait, ice and nitrogen?
Water, ice to liquid nitrogen.
That can happen if it gets cold.
No, girl. The temperature from how cold water is when it freezes. I shouldn't engage that, should I? Yeah. Oh my gosh. You're ridiculous. Huh? But see, here's the thing. I engage you in conversations. I'm like, oh my God, you think that way? Stephanie, your poor life. Okay. Is there a time when the air and ground were the same temp? 5 minutes. That's not right. Where is it? Where are air temperature and ground temperature the same? What? You're kidding. Where are air and ground temperature the exact same?
Right there, I see it.
Right there?
Yeah.
Where else?
Right over there. Right there.
That's a good way to describe it. Don't let them in.
More over.
Don't let them in. Where else? Right here?
Yeah.
Perfect. What's on page 13? The end of the lesson. What's for homework, EJ?
Nothing.
The problem's at homework. Don't let them in. Don't do it.
But they're my friends.
I don't care. Especially don't do it. One more. You need to do the exit ticket for our entry test tomorrow.
Mister, why do you have to say it like that?
The 300.
Because we have 5 minutes.